Good morning, majors. Today we're going to go over our last set of notes, which are going to be Unit 4, Day 9 notes. These are our last set. It says, given isosceles right triangle ABC, this is an isosceles triangle, which means this side is equal to this side, and it's a right triangle, which means it has a 90-degree angle. Find BC. Since it's a right triangle, since it has a 90-degree angle, we can use the Pythagorean theorem. Otherwise, we'd have to use the distance formula, but we can use the Pythagorean theorem on this one. Let's see, the A to C, we're going to go up 1, 2, 3, 4, 5, 6. So this side length is 6. And I know that this is also going to be 6 because it's isosceles. Otherwise, you can count. And then you can find the length of BC by using the distance formula or the Pythagorean theorem. I'm going to show you the Pythagorean theorem, which is a squared plus b squared equals c squared. But remember, your c has to be your hypotenuse, the length that we're trying to find, the biggest side, or the side opposite the 90 degrees. Your a and b, it doesn't matter which order, we're going to say 6 squared plus 6 squared equals c squared. We know that 6 squared is 36. And then I'm going to bring this up here. And c squared equals 36 plus 36 is 72. And if you take the square root of each side, you're not going to get anything nice. But we have to get rid of that c, of that squared in front of the, on top of the c. So we're going to take the square root of each side, and we're going to get c is equal to, you can leave it as a square root of 72, or if you plug that in your calculator, that's about 8.485, which is 8.49. Okay, round it. That's going to be our biggest side is 8.49. We also are going to use the distance formula a lot on here, so I want you guys to go up to the top and write the distance formula on the top of these notes. We're going to check to make sure that it's up there. So the distance formula is x minus x squared plus y minus y squared. And make sure that square root keeps going. It's over everything. Alrighty, let's go down to number 2. It says prove the triangle PSR is an isosceles triangle, which means two sides have to be equal. So we can use the distance formula, or you can just look at the slope. From P to R, we're going to go over to, we're going to do rise for run. So let's go up how many units? Looks like I'm going to go up 1, 2, 3, 4, 5. I'm going to try again. We're going to go up 1, 2, 3, 4, 5, 6, right? So I went up 1, 2, 3, 4, 5, 6 up. And then I'm going to go to the right 1, 2, 3 units. So that's 6 over 3. Let's see if this slope is the same. Am I going to go up 1, 2, 3, 4, 5, 6? Yes. Do I go to the left 3? 1, 2, 3. Yes. Good. So these are going to be an isosceles triangle. So really we went negative 6 over 3. But the distance will be the same, so that is an isosceles triangle. So you can say yes. You can use the distance formula to prove this also. Just find the 2 points and plug it into the distance formula. It says the vertices of A, B, C and the endpoints of D, E have integral coordinates. That means they're actually on the corners that they look like they're on. Plot F with the inner coordinates so that A, B, C is congruent to E, D, F. So this one was on like our test, I think, or our quiz, and on the SOL, something very similar was on the release questions of the SOL. This is just very important that you go in the same order. So they're going from A to B to C. So we're going to go from E to D and then to F.
Please get this back here into the house.
All right, guys. So this one looks a little difficult because this order is kind of flipped. So what I want you guys to do is we will write it in a different order. Let's write it in a triangle DEF. That one's a little bit easier. Let's try that. So A to B is the same as D to E. And then we can just count the slope, B to C, and we know that our last vertex that we have to put down is F. That's how we know what it is, because this is the one that we're missing. So let's look at the slope. I'm going to go up to get to C, 1, 2, 3, and then I'm going to go to the right. Sorry, 1, 2, 3, and then I'm going to go to the right. 1, 2, 3, 4, 5, 6. You can do that a little bit slower on your own paper. Just do it again at E, so D to E, and then we're going to go up 1, 2, 3, and then we're going to go to the right 1, 2, 3, 4, 5, 6, right? We went up 3 over 6, up 3 over 6. So this is the point that F should be at. Let's make it green. And this is, we're going to put F by it. And when you connect the dots, they should make the same triangle. So they want to know, they want you to plot F to be at the integral coordinate. Remember, integral just means on the corner. And I'm going to put what point this point is on the side. So I always label it. I'm labeling it F, and I'm going to put the ordered pair, which is to the left 1, which is -1 for the x value, comma, and then I'm going to go down 2, so -2. Okay, -1, -2. Go ahead and flip your paper over. Use the diagram on the right to answer the following questions. Write the coordinates for points A, B, and C and D. So A, we're gonna have to know how to do this so that we can put it into the distance formula to find the distance between these points. So A is at -5 on the x-axis. The x-axis always goes first, and then the y-axis. So A is at -5, comma, and then the y value is -2, right? So -2. Put it in there. And then B is at -3, and then +5. C, x value goes first, which is 5, +5. I want you guys to try D. Which 2 points have the same x coordinate? So hopefully you guys filled in D correctly, and D is at 5, -4. So it says, which 2 points have the same x coordinate? X is our first number. The one that has the first number the same is C and D, point C and D. Which one have the same y coordinate? I want you guys to fill that in. Which ones have the second number that are the same? Find the lengths of triangle BC and BCD. So we're trying to find the lengths of BCD. This triangle right here. Remember that the word lengths, we're going to use the distance formula or the Pythagorean theorem. Same thing, if you have a right angle like this one, then you can use the Pythagorean theorem. Otherwise, we have to use the distance formula. For the B to C, you guys can just count it. We go over, just count it. You don't even need to use the distance formula. 1, 2, 3, 4, 5, 6, 7, 8. From C to D, just count it. We're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. Check my work, make sure I'm right. Hopefully. Now B to D, you guys can use the Pythagorean theorem. You can say 8 squared plus 9 squared equals B to D squared, which is going to be your hypotenuse squared, right? Your hypotenuse always has to be on the other side of that equal sign, and then square it. Do exactly what I did on the other side. I'm going to show you guys how to plug this into the distance formula again, because we haven't gone over this very recently, and this is definitely going to be on your test. Remember the distance formula? I wrote it on the front of the paper. It's going to be x minus x. So I'm doing B and D. I'm doing these two coordinates right here. So my x, -3, minus +5. squared plus parentheses, I'm going to use my y values, which is 5 and -4. So 5 minus -4 squared. Just plug that whole thing into your calculator, especially if you're on the test. If not, I'm going to show you guys how to solve this. So I have -3 minus 5 is -8 squared plus 5 minus a negative, that will become a positive, that is 9 squared, right? We have 8 and 9 squared. Anything squared is going to be positive. So the distance is equal to 64 plus 9 squared is 81. And if you combine those, 64 plus 81 is 145. I don't think that's a nice number. Just leave it as a square root of 145. If you want to take the square root of that 145, round it to about 12. About 12, kind of 12. And I want you guys to try to do the same thing for ABD. You guys can count for most of it, and then you're going to have to use a distance formula or the Pythagorean theorem. Okay? And then you're gonna explain number 6. Are they congruent? Are all the side lengths equal? And if all the side lengths are equal, you can say yes, they're congruent by side, side, side. I hope you guys have a great night, and we'll finish this tomorrow in class.